Let's work another problem. Here again we have a fraction whose integration we need to do. So we are going to use partial fractions technique. This is the case when the denominator has linear factors, but one of the linear factor is repeating. You notice that it is power 2. If we have that as the case, we're going to split this one fraction into three fractions. The first will be because of x plus 1, but x plus 1 power 1. But because x plus 1 is repeating twice, we're going to write it another fraction. But now the power will be used as 2 plus. There is another linear factor, which is x plus 2. For that, it will be x plus 2. So for each factor you are writing a new fraction, there will be a new constant use. You can use any alphabets like ABC are the easy ones. That's your choice. But it's a common convention to use capital alphabets to distinguish between the variable and your constants. Okay. Now the next step is to make the common denominator. So the common denominator here would be x plus 1 whole square times x plus 2. I'll have to multiply a with x plus 1 and x plus 2 because in the denominator there's just one power of x plus 1. I'll have to multiply b with only x plus 2 because x plus 2 power is already in the denominator. Plus, I'll have to multiply c with x plus 1 whole square. Excuse me. On the left hand side, we have x square, the same thing. Now you notice from left hand side and right side, the denominators are same. So the numerator will be same too. So we can say x square plus x plus 1 is equal to this whole numerator. Now from here, we need to somehow, our goal is to figure out the values of A, B, and C. That's the first goal, okay? So for that, what I'm trying to say here is that this statement is true for all x. So this should be also true for, say, x is equal to -1. So I'm going to plug in -1 everywhere. Where did I get -1 from? From one of the factors here, okay? So let's put -1 in place of x everywhere. When I put -1 here, this whole thing will become 0 because -1 plus 1 is 0. So this whole thing will become 0 plus b times -1 plus 2 plus this also will become 0 when I put -1. So what we'll have left is 1 equal to b. So we got b value from x equal to -1. Similarly, this is also should be also true for x equal to -2. Let's try that. So in place of x everywhere, now I'll put -2. -2 square minus 2 plus 1 equal to, now again this first factor will become 0 because I'm putting x equal to -2, plus this factor will also become 0, plus when I put -2 here, this will be 4 minus 2, 2 plus 1, 3 is equal to, this would be -2 plus 1 is -1 square c. So c is coming to be 3. Now we already got A, B, and C. A is still left. As I said, this is true for all x. So it should also be true for, say, x equal to 0. You can pick something which will help you calculate it easily, okay? So plug 0 everywhere. 0 plus 1 on the left side, right? Here, A times 0 plus 1, 0 plus 2, plus B times 0 plus 2, plus c times 0 plus 1 whole square. Let's see what this gives you. 2a plus 2b. In place of b, I can put 1 because b is 1 plus c. Sorry, in place of c, we can put 3 times 1. So basically 2 plus 3 is 5. 2a plus 5 equal to 1. 2a, subtract 5 on both sides. So 2a is negative 4. A is negative 2 by dividing by 2 on both sides. So we figured out all three constants. That means using these three constants and our starting fact, we can say that this integral can be written as, let's write it down, negative 2 by x plus 1 plus b is 1 by x plus 1 whole square plus c is 3 plus 3 by x plus 2 dx. That means what I'm saying, that this fraction can be written as this instead using our work on this side. So now last thing we need to do is integrate this. So let's do that. We can separate the integrals out, negative 2 out. This is x plus 1 plus, with respect to x, integral of 1 by x plus 1 whole square plus 3 integral of 1 by x plus 2 with respect to x. Now you should remember your formulas. Integral of 1 by ax plus b is 1 by a natural log of ax plus b plus c. And you know, if we have an integral of 1 by ax plus b power n, that can be written as ax plus b power n. Okay, so that can be treated as power rule actually. So, but the power here is negative. Okay, so power rule, if it's a linear function inside instead of x with the coefficient of a, would be 1 by a ax plus b's power add negative n plus 1 by negative n plus 1. Okay, that's how you're going to do this using the power rule. So let's work on this. Negative 2, this first one would be just natural log of x plus 1 plus this one can be written as x plus 1 power negative 2 plus this one is easy using natural log x plus 2 plus c. Pay attention because the coefficient here of x was 1. I didn't need to divide by anything. Okay. So negative 2 natural log of x plus 1 plus this one can be written as using the power rule. So coefficient of x is 1, so we don't really have to worry about a here. Negative 2 plus 1 by negative 2 plus 1 plus we have 3 natural log of x plus 2 plus c. So our final answer, this is negative 1, so negative 1 by x plus 1. Why? Because x plus 1 power negative 1, that becomes negative 1 and it has to go denominator. 3 natural log of x plus 2 plus c. This is your final integral answer. This technique is called partial fractions. This example was when we have linear factors repeated linear factors. So on the right hand side, I'm showing you how you use partial fractions to split our fraction into simple fractions here, and then we can apply our rules.